Hey everyone, my name is Lutfi, and in this video we will be talking about isomers. Okay, and these are the main subjects that we will be talking about in this video. And so without any further ado, let's get started with our video. Okay, so in the previous video we talked about the variations in organic molecules, and so the variations that are in uh, the architecture of organic molecules can be seen in isomers. Okay, so in total, the definition of isomers is compounds that have the same number of atoms of the same element but differ in their structure and hence their properties. Okay, and in this video we are just going to talk about three of these isomers, meaning structural isomers and cis trans isomers, and last but not least enantiomers. Okay, so let's start with structural isomers. Okay, so the main difference of these isomers is the covalent arrangement of their atoms. Okay, and here's an example. Okay, so both of these molecules are their formula is C5H12, but they differ in their covalent arrangement of their carbon skeleton. Okay, so one, as you know from our previous video, one of them is straight and the other one is branched. Okay, and as you might have found out, the number of possible isomers increases tremendously as carbon skeletons increase in size, as shown in this picture. So let's look at this picture or table more in depth. Okay, first things first, this table is made specifically for alkanes. Okay, so these alkanes are a kind of carbon skeleton that all of the bonds of them are usually a one carbon bond. Okay, and okay, so let's go to the table. As shown in the table, we have only three structural isomers of C5H12, which is shown by C5. Okay, so in this table they have just written the number of carbons a molecule has. Okay, and as you can see, we have only 18 variants of C8. Okay, so the molecule that is mostly known as octane, and there are 366 no, sorry, 366,319 possible structural isomers of C20, which you can find the name of this molecule in the internet. Okay, and have in mind that the structural isomers may differ in the location of the double or triple bonds, if the molecule even has any. Okay, and have in mind that the carbon skeletons that have double or triple bonds are differently named in relation to alkanes. Okay, and one of the groups that I can remember is called alkenes, and I think they even may have triple bonds in their structure as well. Okay, so now let's talk about cis trans isomers. Okay, so in cis trans isomers, these carbon atoms have double bonds with the same molecules, but because the double bonds are not flexible, meaning that they don't rotate, the atoms or chemical groups that are attached to them, thus they differ in their spatial arrangement. So let's learn with an example. Okay, so if a double bond joins two carbon atoms, okay, and the example is in the picture on the bottom left corner. Okay, so continuing, if, for example, a double bond joins two carbon atoms and each carbon atom also has two different atoms, okay, or groups of atoms attached to both sides, okay, they would make cis and trans isomers, okay, because as I said, the double bonds don't rotate, okay, and so they can have two different structures, okay, so they make cis trans isomers. So you are all now wondering that which one of these two are the trans or cis isomers. I know the picture has given the answer, but let me tell you how. Okay, so consider a simple this simple molecule, okay, which has the hydrogen attached to one side and the X attached to the other, okay. So the arrangement with that has the both X's on one side of the molecule, okay, as shown in this picture, which the X's are on the, how do I say it, north side of the molecule. This molecule is known as cis isomer, okay, and if both of the X's are on the opposite sides, as shown in the right picture, right part of the same picture, that isomer is known as trans isomers, okay. So the subtle differences in shape between such isomers can have very dramatic effects on the biological activity of organic molecules. Okay, so an example would be the biochemistry of vision, which involves a light-induced change of retinol from the cis to the trans isomer, and aka retinol is a chemical compound in the eye, okay, and we will talk about that in the future, okay. And another example is the cis or trans fats, okay, and I am sure you have heard seen this on the bags of your groceries, okay. So one of them, which is that are the trans fats or the bad fats, they clog our blood vessels, and in very severe cases they can cause stroke or a heart attack in people, okay. So yeah, the difference between cis and trans molecules are very important, okay. So now let's change some gears and talk about enantiomers. So enantiomers are isomers that are mirror images of each other, and that they differ in their shape due to the presence of an asymmetric carbon, meaning that different atoms or chemical groups are attached to a carbon, making it asymmetric, okay. And you can see this in this picture. And you can also think of enantiomers like the left and right hands, okay. Just as you can fit the right hand into the you can't fit the left hand into the right handed glove, okay, without turning it, okay. The right-handed molecule won't fit into the same space as the left-handed version, okay, and you can't even turn these molecules in the 3D space to fit themselves in each other's spaces, okay. And a very important fact is that usually one and only one isomer is biologically active, and that's because only one form can bind to specific molecules in the organism. And a very important fact is that the concept of enantiomers is very important in the pharmaceutical industry, because the two enantiomers of a drug may not be usually effective, okay, as shown in this picture, okay. And so that was all for this video. I hope you enjoyed it. And so, as always, until the next video, happy learnings to you all.